So I wanted to give a big picture from week 8 to week 10. What are we doing at each week, and what do we expect to achieve here? So we have a continuous plant to start with, and we wanted to end up with discrete time controller. That's the overall goal of this subject. There are two different paths way to go there. One is we discretize the plant to get a discrete plant model. Then we do a digital design. So this is where we do a digital design. So a lot of mathematics is trying to go this path. However, this is not the design method we actually use, because here we involve a lot of Z domain analysis. So the tool in here is very similar to S domain analysis, but it's kind of a new set of tool. You have to learn quite a lot of new stuff to be able to do this. So we actually, what we did is we start from continuous time plant. We design a continuous controller, and then we do discrete size, get discrete size controller. So in here we consider sampling and zero order hold. So the effects of these two, we do some compensation, then we just discrete that like a discrete time controller. So a lot of information we learned in week 8, week 9 is somewhere here. However, we don't actually use that in the design by emulation in week 10. Okay, so that just sometimes brings all the confusion there. So week 10, pretty much you can say it's stand alone, like you can go from this path to get things done. A lot of Z transform stuff in week 8 and 9 is not necessarily being used here. Some of them are. So to get a big picture, let's start plotting. Say, if I have a control system, I have this reference signal in time domain, and we have a plant. That's what we want to control. In this is in S domain. So the goal is we're trying to say our output of the plant needs to follow the input. All right. So for continuous time design, we just design a controller over here. We do a feedback. That's it. So what happened to the discrete time system here is things in between. So here we do a sampling. All right. So you get RT. This is YT. Then this is the arrow signal. From the sampling, from this point, the arrow signal becomes a sample. And over here is our computer. So computer take this arrow signal to generate our control signal, which is UK. So in discrete time domain, you get a EK to generate UK. And this UK through the zero order holder become the control signal UT to drive the plant. So that's the whole workflow. In week 9, we focus on this sampling. This is week 9 content, and also this bit, zero order hold. How do we say already have a time domain? We wanted to get the continuous. We got a discrete signal. How do we get to a continuous signal? By zero order hold. So those are the two parts we cover in week 9. And in between, because the computer, you take EK and UK, the algorithm here, the controller here, CZ, it's very difficult mathematical relation in time domain from EK to UK. If you remember, in time domain, the system we have to do convolution of the system and the input signal to get the output. And convolution pretty much is the integration of a series of signal. It's very hard to mathematically do it. So to make that part easy, what we do is we convert EK into EZ and convert this UK, sorry, from UZ, and design a controller CZ to achieve that. All right, so this is why we need to do the Z transform and inverse Z transform. This is what we did in week 8. So summarize, week 8, we look at the Z transform. So that's pretty much how we go from time domain to Z domain to get the controller design. Okay, we did not actually say, we did not actually design because this is kind of a long story that's need a lot of Z domain analysis. We just say, how do we actually do the conversion there, assuming the design is there. Say this controller is already known, but we didn't do that. If we actually do that part, then we're going to this pass. This is what we do to do the design, but we didn't do that because a lot of knowledge needed. It will take 2 or 3 weeks just to do that one. So actually what we do is on the left hand, we actually did this. Okay, so in that point of view, what we do, a lot of things here is kind of opposite. We don't really do those things. We consider here, this computer is just a CS. That's our controller. Then this sampling component, this sampling is basically a low pass filter. If you link this together, then zero order hold and the plant. So this is will be zero order hold of the plant model. So we pretty much convert everything into S domain. So consider all this discrete time system is just a continuous system. So with the addition of zero order hold and the sampling, which causes the low pass filter. Okay, so we consider these two things in our design. Then we only design this continuous controller. Then this continuous controller should work the same as our digital controller. So in here, we just get a CZ because we actually have a controller. We have a computer here. Okay, so we say if we consider this low pass filter and zero order hold, this digital controller will perform exactly the same thing as the continuous controller without those two things. Okay, so this is where we call design by emulation. Okay, so a lot of things we learned in week 9 over here might not be useful. Seems not useful. You do a lot of kind of conversion, but in the end, if we do the design by emulation, you do this zero order hold and you do a sampler. That's it. Week 10, we're going to look at how do we do this Z domain to S domain conversion. There's a lot of different ways to do this mapping, call this mapping, to achieve certain requirements. This is also a mapping, one way of the mapping, but there's many other ways. So this is how I put all things together. So hopefully, okay, this is a week 10. Okay, what we do is week 10 in here. So hopefully you get a better, clear image after this. Thank you.